So when you look at this particular one, you only have one set of sides. By that, I mean you only have one pair of sides that they both have the number 2. And so that's the ratio you're going to set up. And so the ratio you're going to use is the 18 to the 24. The 18 to the 24. And so you're going to put 18 over 24. Now, when you do this, you wouldn't want to cross multiply right here because those are larger numbers. If you can simplify your ratio, go ahead and simplify it. So when you look at this, what goes into both 18 and into 24? Something bigger. 6 goes into both of them, right? So you can reduce that to 3 over 4. And that's what you want to use, because if you use the 18 over 24, while you'll get the right answer, you'll have much larger numbers. And so then you want to take that ratio and you want to use it with the other two sides. So we're going to take that 3 over 4 and we are going to set it equal to the 9 over the n. The 9 over the n. And then you can use cross multiplication here if you want to. So 3n equals 36. Divide and n equals 12. You're going to use that same ratio for the next set. So you're going to say 3 over 4 equals the 12 over the m. And again, you can cross multiply. 3m equals 48. So m is going to equal 16. So you're just going to use cross multiplication for that one. The desired mixture of grass seed for overseeding a lawn is 70% bluegrass and 30% ryegrass. All right. So that's your first ratio there. It's 70 to 30. And make sure that if you put bluegrass on top and ryegrass on bottom, you're going to do the same thing for the next one. It's just order matters. All right. If you would put rye on top and bluegrass on bottom, that's fine as long as you do that in the next set. I would reduce this. Again, you have 70 over 30. You don't want to do cross multiplication with that. So reduce it by 10. So 7/3. And it says how many pounds of ryegrass. That's where my X is going to go. So because my rye was on bottom here, that's where I'm going to put my variable. Should be mixed with 40 pounds of bluegrass. My bluegrass was on top for mine, so I'm going to put 40 here. And then you're going to cross multiply just like we did. 3 times 40 equals 7 times x. And when you divide that out, you do get your decimal there. So it was the same setup as all the other things we just did. It was a ratio. Proving that things are similar. So with congruence, you have to prove that every single piece, or at least certain pieces, are the exact same. For similarity, the requirements are not as stringent. So we have similarity. The first one we're going to look at is angle, angle. If you can prove that 2 angles are congruent, you can say that the 2 figures are similar. All right? Now, you can't say they're congruent because if you recall, we did not have an angle one in our congruence. But if you can just prove that 2 are congruent, then you can say the whole thing is similar. And so you can see here that they have that angle A is congruent to angle X and angle B is congruent to angle Y. So then we can go ahead and assume that the 2 triangles are similar. So if any 2 angles of one triangle are congruent to 2 angles of another, then the 2 triangles are similar. So this example that they have here, can this be shown to be similar? Can we say that this first one here, which is the larger triangle, is similar to the smaller triangle? Do we know that? So really all we have to do is say, can we say that 2 of the angles are congruent? So I can say that this angle is congruent to that angle. Why can I say that? What type of angles are those? Vertical angles. All right, there's one. These little notations here tell me what about the lines? They're what? They're parallel, all right? And so way back in your brain, parallel lines create alternate interior angles, which you actually could have just used that if you wanted to. Alternate interior angles, all right? So yes, this one actually, you can say that yes, this one would be similar because the transversal or vertical. Look at the next one. All right, we know right angles, so we have some congruence here. If that's a right angle, this is a right angle, that's a right angle. All right. Can we say anything else about those as far as angles go? They did not tell me that these are parallel. So all I have is one angle. So you cannot assume those are similar triangles. You cannot make that assumption. All right. Look at the last one. A right triangle with a 35-degree angle and a second right triangle with a 55-degree angle. Can we say those two are congruent or that they are similar? We know they're right triangles, so we know we have at least one angle, yes? All right. If this guy has a 35, what is his other angle and how do we know? What's his other angle? All triangles have angles that add up to 180, right? So if this is 35, the other two have to be equal to 90. What happens when I do this? So yeah, those are also similar triangles. They're similar. We don't know that they're congruent, but we know they're similar. All right, so all you have to have is two angles. Let's look at the next two, and then we're going to try some. Side, side, side. This is different than congruence. In congruence, we said that they all had to be the same length. All right? They had to be the same length to be congruent. Here, it says the three sides are proportional. All right, so just like we did in the last section a little bit, are they similar? You can set up proportions. And if all of your proportions are equal, then you can say they are similar triangles. That's what your side, side, side means here. And then side, angle, side. Again, we're looking at similarity, not congruence. If two of your sides have the same exact proportions and the angle in between is the same angle, congruent, those are similar figures. All right, so let's look at these three ways to do it here. Let's look at the first one. Example 2. If the triangles can be proved similar with the given nation, write a similarity statement. If not, tell me why. All right, so this first one doesn't give us any information about angles, right? It only gives us information about sides. So they want to know if these are similar. So then you have to pay attention to orientation, all right? If are these facing the same direction? No, right? And they don't give us any information as to what order it goes in. So for this, I'm going to use my logic skills. My shortest side should correspond to my shortest side. Does that make sense? So my shortest side on my XYZ is the 9, right? Which means it should correspond to which side on my QPR? My 12. And so we're going to compare those two. We're going to say 9 over 12, all right? Which means that my next shortest side, which is 12 on this guy, should correspond to 16. So we're going to say, does that equal this? And then the last one would be my 15 compared to my 20. My rule says that those all have to be the same fraction. So the only way to tell this is to reduce it. So what does this reduce to? What goes into 9 and to 12? 3, right? So this is going to be 3 over 4. What goes into 12 and into 16? 4, right? And what goes into 15 and into 20? 5. So yes, they are similar. All right, they are. Now it wants me to write a similarity statement. Order matters, okay? And so pay attention to how you write this. So I would probably go from my shortest side maybe to my longest side. So I would go like from X to Z and then to Y. Similarity. And then I would start with my shortest side here. So I would go from Q to P. That's my shortest side. Make sure that that corresponds to your shortest side. And then to R. That's my similarity statement, okay? It also asked me to name the theorem. So which did we use? Did we use the angle theorem, the side theorem, or the side angle side theorem? Which one did we use to prove this one? The side. All we did was use sides. So the next part of this would just be writing that we did side, side, side. All right, so you would say, I did that by my 3 sides. And then that entire thing would be your answer. So on a quiz or test for me, you would want to make sure you wrote it in the correct order and that you gave me the postulate that proved it. All right. Look at the next one. Look at the next one. Did they give me any information about angles? Did they give me any information about angles? Not necessarily, but a little bit. What did they tell me? Vertical angles, right? So even though they didn't tell me specifically, I can assume this because they're vertical angles. I cannot assume any other angle. So I definitely know that my angle is out. All right. They only gave me two sides. So I also know that my side is out. All right. So my only other option is side, angle, side. What is the problem with side, angle, side here?
You don't have the right sides.
I don't have the right sides. In order to prove this one, I would have to have the sides on either side of the angle, and I only have one of them. So I cannot make any assumptions here. I cannot prove it. So you don't even have to worry about setting those sides up. They're not going to help you. They're not going to help you here. All right? Does that make sense? All right, so let's try some of these. We'll go back to that. All right, so at the top are your three theorems. 1 and 3, they want you to say, can they be proven similar? If they can be, write the statements, the similarity statement, and tell me the postulate that proves it. They told us that B is congruent to F and that C is congruent to D. So we automatically have one. Which one do we have? We have angle, right? Two angles. So order matters as to how you write your similarity. If you wrote it ABC, that's fine. Then it would have been EFD. AA similarity would have been your answer as far as that goes. What's important is that A corresponds to E, that B corresponds to F, and C corresponds to D. So how you put the first order doesn't matter, but your second order has to correspond to your first. All right? What about the second one? Can you prove that these are indeed similar? Yeah, so obviously the only thing you can even test here are your sides. And so you want to test your smallest side. In this case, it was 4 to 8. So 4 to 8 compared to your next smallest, 6 to 12, and 8 to 16, which those all reduce to what? 1/2, right? Hopefully. And so, yes, those are similar by side, side, side. Again, M corresponds to R, N corresponds to Q, and O corresponds to P. All right? Here, the altitude. Altitude is the perpendicular distance to the hypotenuse. Hypotenuse is the longest side of your right triangle. Separates the original triangle into two triangles that are similar to the original. All right? So my original triangle here is this ABC triangle right here. This is my original triangle. My hypotenuse of my original triangle then is the AB side. All right? My altitude of my original triangle is from C to D. What they are saying is that altitude split this guy into two triangles, as you can obviously see that it did. And those two triangles are similar to the first one. So all three of my triangles, my original ABC triangle, the triangle that's on the left here, the AC to D triangle right here, they just flipped him, this right triangle. And then this third one, my CBD triangle. All three of those are similar triangles. So all three of these are similar triangles. This one is similar to the little tiny one. They're all similar to the original one. All right? Because they're similar, it creates ratios, right? So we know the ratios are the same. But what it also produces, it produces a proportion, and it's specifically one that is called the geometric mean. Based on these proportions that is created from your altitude, remember we had extremes and we had means, right? Geometric mean is the square root of those two multiplied. So the square root of those two multiplied is called your geometric mean. And they give this example here. 16 over 8 equals 8 over 4. 8 equals the square root of 4 times 16. All right. And that's what's created with this. That's what's created as a geometric mean. So the first thing we're going to do is we're just going to calculate geometric means between any two numbers. And then we're going to look at it how it applies to right triangles. Find the positive geometric mean between each pair of numbers. So when you see that question, find the geometric mean, you are literally just going to take the square root of the product. That's all you do. So for 3 and 27, you are going to say the square root of 3 times 27. That is the geometric mean. When you multiply 3 times 27, you get 81. And of course, we know the square root of 81 is 9. So the geometric mean of those two numbers is 9. That is the geometric mean. When we get into geometric series in Algebra 2, you're going to use the same term. It means the same thing. All right? The square root of the products. So then look at number, or 1b here. The geometric mean between 6 and 9. All right? We're simply going to take the square root of 6 times 9, which is the square root of 54. Now, 54 does not have a perfect root. If they want it in decimal form, they will ask. If they want exact value, you're going to use your factor tree. And they already did 6 and 9 for you, so you can just use those two numbers. But remember, if it pairs up, it can come out. So we're going to take a 3 out. If it does not pair up, it stays in. So 2 and 3 stay in. 2 times 3 is 6. So my geometric mean here is 3 square root of 6. 3 square root of 6. All right? So geometric mean is strictly just the square root of the products. That's all you're doing, square root of the product. When you have that altitude, it creates these segments that are all divided here. And the first one we're going to look at is the altitude. The altitude here, right here, becomes part of these ratios. And you'll notice it is used right here and right here. And so what happens is the altitude is going to end up being the geometric mean of the two parts of the hypotenuse. Okay? So what happens here is if I have my right triangle and I have an altitude, like they've given me here, then I can find it by saying, well, that h, that altitude, in this case the h, is going to equal the geometric mean of my x and y. So you could have one piece of your right triangle and you can find the other pieces using geometric mean. All right? Something else happens with the legs of the original right triangle. So again, we're talking about the legs of the original right triangle. The leg of the right triangle is going to be the geometric mean of the piece of the hypotenuse that it is attached to and the entire original hypotenuse. All right? So what happens here is, for this case, the B is going to be the geometric mean between the x, the piece that is closest to the B, and the x plus y, or the original hypotenuse, the entire hypotenuse. The A, which is the guy over here, is going to be the geometric mean between the piece of the hypotenuse that is closest to it and the entire hypotenuse. All right, and the entire hypotenuse. So all of those are created by that one altitude. By that one altitude, it creates all of those features in a right triangle. All right, so let's look at this. Find the value of all of these pieces. Find the value of all of these pieces. All right, we're going to start with the altitude of my original triangle. So my original triangle is going to be the large one. This is my original triangle. All right, we're going to start with this altitude piece. So the H is going to be the geometric mean between the two pieces of the hypotenuse. It's going to be the geometric mean between those two pieces. So we're going to say that H is going to be the square root of 4 times 16. 4 times 16 is 64. And so that is going to be 8. My H then is going to be 8. All right? Then we're going to look at my T and my R. So my R, we'll start with this one. That's going to be the geometric mean between the piece closest to it. So the piece of the hypotenuse that's closest to it, the 16, and my entire hypotenuse. How long is my entire hypotenuse here? How long is my entire hypotenuse? I have 16 and, right, Brayton, how long is it? Yeah, it's 20. All right, 16 and 20. And so I am going to multiply my 16 and 20, and that's actually not going to give me an exact. So it's actually going to be 8 square root of 5 when you simplify it. And remember, you can use your factor tree here, so you can do this right here and keep going. It goes forever. But you end up taking out an 8 and you end up with a 5 on the inside. All right, so I can take out 2, 4, right, 8. So I can take out those, and then what's left over is a 5. So 8 square root of 5 is my R. All right, and then my T is going to be exactly the same, except I'm going to use this piece of the hypotenuse, the 4, and I'm going to still use my entire hypotenuse, which is 20. So this is going to be the square root of 80, all right? Which ends up being 4 square root of 5 when you simplify it. You get 4 and 16. So 5 and 16, so 4 square root of 5, all right? So those 3 geometric means are created with that one hypotenuse, or that one altitude. So let's show them. All right, the first one is finding the geometric mean just between 2 numbers. The next 2 are using what you have to find all of your geometric means. To find all of your geometric means. For number 9, they actually gave you the entire hypotenuse. So pay attention to that one. That 18 represents the entire hypotenuse. So if you are given the mean and you have to solve back into it, make sure you remember to square both sides. Square both sides and then solve. All right.